Hello everyone, welcome back to another LeetCode problem. Today we are doing number 238. This is the product of array except self, a medium rated question. It reads, given an integer array nums, return array answer such that answer at I is equal to the product of all the elements of nums except nums at I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. Now it got cut off in this picture, but there's also a follow-up that says, can we complete this problem in O to the 1? Sorry, let me just read it. Yep. Can you solve the problem in O to the 1 extra space complexity? The output array does not count as extra space for space complexity analysis. Okay, now before we look at that, let's try to understand the question. What does it mean? What does the product of the array except self mean? Well, if we are given some nums array, call it nums, and this array stores a bunch of integers. In this case, it's 1, 2, 3, and 4. Well, the product of these arrays would be another array of the same length. Now, what does this array contain? It contains, well, it contains the product of every single other element. And what does that really mean? Well, for this first item right here, it'll be the product of 2, 3, and 4, but not 1, because we want the product of everything but self. So here would be 2 times 3, which is 6, times 4, which is 24. Okay, now how about the second item? It would be everything but the 2, so it would be 1 times 3 times 4. That would be 1 times 3, which is 3, times 4, which is 12. Third item, 1 times 2 times 4 is 8. And the last item is 1 times 2 times 3, which is 6. And that's all this is. Now, a very simple approach would be to get the product of all of these items combined. And then from there, well, we calculate it first, we get 24. And then from there, we would initialize our array as 24 and go item by item. We would divide by whatever the corresponding number is. Well, 24 divided by 1 is 24. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. And that would make this problem very easy. But it is a constraint that we're not allowed to use any division whatsoever. Okay, now how do we do this? Well, first I'll show you how to solve the problem without the follow-up of extra memory, and we will look to solve it without it after. Now, okay, if we look at this array right here, 1, 2, 3, and 4. Well, what is the product of everything but 1? Well, it's all the products to the right times all the products to the left. In this case, there's nothing to the left. Okay, so let's use a different example. Let's use this 3. Well, if we were to calculate it, it'd be 1 times 2 times 4, which is equal to 8. But if we were to look at it this way, we would get all the products of here first, which is 2. All the products of here, which is just 4. 2 times 4 is 8. If we were to look at a longer array, for example, just to prove this point, and let's say we want everything but the 10. Well, we want everything to the right, which is 2 times 4 times 6, which is 8 times 6, which is 48. And then we would have 11 times 2, which is 22. And our answer would be whatever 22 times 48 is. And if we were to just look at it without using this approach, it would just be 2 times 4 times 6 times 11 times 1 times 2. And again, because of multiplication laws, this is the exact same thing actually, because we can multiply in whatever order we want. But what does this mean? This means that we can actually go through the array and process the left products and the right products and then combine them for a solution. Because O to the n does mean that we're only allowed to iterate through the loop, but that doesn't mean once. It could be 1 time, 2 times, 3 times, 4 times, as many times as we want, as long as it is a set amount for every single example. It can't be n amounts, because then that would be n squared. Okay, so let's stick with this example that we created, just because it is a little bit more complex, so it should be a little bit easier. 10. Now, what we can do is we can initialize a left and a right array. Now this does use additional space. I will show you how to do it without it in a second after this. We will create these arrays to be of the same length, and they'll hold the number 1. And that's because we don't want to use 0, because anything multiplied by 0 is 0. 1 doesn't have any effect on multiplication. Okay, now we can do the left one first. Okay, these are done separately, we won't do them at the same time. And for the left, we will go through the array in order. And how do we do that? Well, we just check the previous term, or what we can also do is just okay, we will start at this 2, and we will just take whatever the previous term times that 2 is, and that would be 1 times 2. Notice we skipped the first item because to the left of the 2 is nothing, so it's 1. So technically this 2 is to the left of the 4, right? Hope that makes sense. So now at this 4, well, we just did the 4. At this 6, okay, everything to the left. So that would be whatever this item is times whatever this is, which is 4 times 2, so 8. Now we go to this 10. Well, it would be whatever this 6 times 8, which is 48. Now, why are we doing these operations? It's because this 8 is everything to the left of the 6, and we want to include the 6 in order for it to be everything to the left of the 10. Okay, that seems simple enough. So this is a 48, and from there we keep going. We get this 11, and that would just be 10 times 48, which is 480. We get this 1, which would be 11 times 480. I won't do it right now, but and we get this 2, which ends up being 22 times 480. Okay, now how do we do the right? How we do that is we do the exact same thing, but instead of going in order, we go in reversed order. Okay, so again, we skip this 2 because there's nothing there, and we just start at this 1. This 1 will be wherever the, well, this is the 2, this is the 1, these are the two numbers that we multiply, we get this 2. Now we end up at the 11, so we multiply the 1 by everything before it, which is 2, and we get 2 again. Oops. Now we are at 10, we get this 11, everything before it, we get 22. Now we're at the 6, we get this 8, not the 8, sorry, we get this 10, everything before it, which ends up being 220. Get this 4, well, we are at the 4, we get the 6 and everything before it, which is just 6 times 220. We're at the 2, we get 4 times this, and we end up with 24 times 220. Okay, now what? Now we create a output array, and all it does is it combines the left and the right. Well, everything, what's to the left of 2? Just 1, because there's nothing there. We don't want to affect it, we don't want to use 0, so it'd be 1. What's to the right? Well, it's 24 times 220, so that would just be 24 times 220. And then we go to the 4, it would just be 2 times 6 times 220, which is just 12 times 220. I probably should use smaller numbers. And then we go here, and so on. But anyways, what I'm trying to prove is, well, this would be some number. Actually, no, the next one is 10. Let's do 10. Let's pretend we did all of these, and here we got to this one, this 10. It's what? 48 times 220. What did we have before? That's exactly what we said. It would be 48 times 220. because if we were to combine all of the left, all of the right, we get 48 times 220. Okay, so that proves that this works, and it is within the time complexity of O to the n, because we are iterating through it 3 times, but that is still linear time, because regardless of the test case, we'll always go through it 3 times. Now, how do we do this with constant space? Well, not necessarily constant space, just no additional space. So we're allowed our output array that can be as big as we want. Well, we know its length is already going to be the same length as the nums array. But okay, let's just use the 1, 2, 3, 4 nums. Just keep it simple for this example. 1, 2, 3, 4. Okay. Now, we didn't need a left and a right. Not really. We could have just used this nums to just update it and done the product operations right on the numbers. And how do we do that? Well, we're still going to do the same thing where we iterate through the numbers in order for the left. And we're going to initialize some I pointer. We're going to go through in a for loop. But we're also going to have some variable left, which keeps track of all the products to its left. And since we want to start off with 1, because 1 doesn't affect it if there's nothing there. Okay. And well, we just want to multiply this by whatever is to its left, and that's 1. Okay, then we want to update this left. We multiply this 1 by the 1, so it's still 1. And you'll see why that is in a minute. Now we go to 2. Well, what's the next output in 2? Okay, one thing I forgot to mention, we are going to do this. Okay, we will pre-initialize it with 1, and what we're doing is actually we're multiplying this 1 by this, because we're not allowed to multiply this. It's everything but itself, right? But now that we are at this item here too, what we will do is this I is actually also pointing to output. It's the same thing, really. The indices mean the same things. They are different numbers, but they're same positions. Okay, now we're at this 1, and we want to multiply it by everything to its left. Now pretend we're at this 2. Everything to its left is just this 1, which is also the 1 here. So multiply it by 1. And we want to update this 1 by multiplying it by the number itself, which is 2. So it becomes 2 times 1, which is 2. And this makes more sense now when we are in 3, because here we want to multiply by everything to the left of 3, which is what? That number is just 2. So 2 times 1 is just 2. Okay. And we want to update 2 to 6. Because once we get here, we want to multiply by everything to the left of 4, which is just 6. And if we were to update it, this doesn't affect it because we're done. 24. Because if we were to have some number here, everything to its left is 24. Okay, that seems pretty simple. But this is the output. This is the products of the array, but itself, while only taking the elements to the left of each number. Okay, now how do we take into account the right? Well, we do the exact same thing. We traverse it, but in the backwards direction. So we have some variable right, and that starts at 1. Okay, now we have this, and we're going to multiply it by everything to the left of 4, which is just this. Okay, so it stays at 6. Now we're at 2. We want to multiply it by everything to the left of 3. But in the last step, we forgot to update this. We got to go 1 times 4, which is 4. And everything to the right of 3 is just 4. So 2 times 4 is 8. Okay, now we're at this point. Well, let's not forget to update it again. And oops, we said this is 8. And now we want to update this because what was this before? It was 4, but now we've got to multiply by 3, it becomes 12. Now we're at this point. I'll multiply by everything to the left of 2, which is 12. Okay, now we have to update this and it becomes 24. and now we're at this 1, multiplied by everything to the left, to the right of 1, and that is 24. And now that we've gone through the left and the right, this output is ready to be returned. And again, this has the same exact time complexity, takes the same amount, it goes through it the same amount of iterations. The only difference is now we're not pre-initializing those arrays. We're not using any extra space. So now let's head over to LeetCode and see if we can code up this solution. Okay, now that we are over in LeetCode, let's begin by writing this solution. Now let's first create some variable n that will just store the length of nums, because we will use this a couple of times to make our code look clean. And let's just pre-initialize our results array, and that will store numbers, the integers 1 for a length of n. We choose 1 because it has no effect over the products. Now let's sort out the left products, and we'll create the variable which stores all the products to the left of whatever integer we're at. We will create a for loop which goes through every single number until n, and that just means that we are able to update result at that number I by whatever we have stored to its left, which is a variable left. Now before we move on, we have to update our variable left by including the number that we missed, which is the number at nums. And we missed it because it's an exception. We don't want to include it in the product. That's everything. Now we do the exact same thing for right. We can even reuse some of these variables to save more memory. But let's just keep it like this so it's easier to read. And the only difference is we are reversing the range because we want to go backwards. We can still go n, and we update the result to I by right, and we have to update right before we move on by the number that we ignored in the previous operation. That's everything. From here, we just return result. And if everything is good, we can check. There you go. That's pretty well. Now again, this is in O to the n algorithm. You don't see any for loops nested inside or anything, and all of these operations are O to the 1. Well, thank you guys for watching, and I'll see you guys in another video.